Okay, these are the notes for Unit 8, Day 3 on proving it's a parallelogram. And we're going to look at this, and we're going to look at this handout that I gave out. And this first part of this handout just goes over the same 5 rules that we've been talking about on our little foldable, our little fortune teller, and on day 1, and that stuff. It goes over the definition of a parallelogram, that opposite sides are parallel, and here they are. It goes over the 5 theorems that went with parallelograms that we've been talking about. A parallelogram has 2 sets of opposite sides that are congruent. It has 2 sets of opposite angles congruent. It has consecutive angles that are supplementary. The diagonals bisect each other. And it also tells us that it happens to be that this triangle is congruent to this one. If you remember back when we did congruent triangles, if I know this angle is equal to this angle, and I know this side is equal to this side, and this side is equal to that side, this is our side angle side. We also know that that side in the middle is equal to each other, so we know those 2 triangles are also congruent. And we've been seeing all these same properties for the last 2 days. These are not the new thing. The new thing is the bottom where it says, use the following to prove that it's a parallelogram. And what I want you to notice is that really there's no new information here. This is really just the converse of the stuff that's written at the top. Remember our if, then, inverse, converse. Converse is where we just switch the if and the then parts. So let's look at what it has. The theorem up here says, if it's a parallelogram, opposite sides are congruent. Then right here it says, if opposite sides are congruent, then it's a parallelogram. So if you look at each one of these, this is literally exactly the same stuff that we had at the top. It's just that we've switched the order. We do have this one extra one here at the bottom that says, if one set of sides is parallel and congruent, then we know it's a parallelogram. So this is the only one that's different from the top. So we have 1, 2, 3, 4, 5 different ways that we can prove something is a parallelogram. And we're going to be using those. Okay, so let's look at our notes now. So over here, it says, are you given enough information to determine whether the quadrilateral is a parallelogram, and explain? So what we're going to do is we're looking at these over here and saying, does it tell us one of these things right here? Well, this first one says this is congruent and this set of sides is parallel. Well, that happens to be this one right here where it says one set of sides is congruent and parallel. So that's this one here. And I'm just going to letter these so that I can put the letters over here and I don't have to write them out. But you can write it out or you can put the letters whichever way you want to do on your notes. Parallel and congruent. What is the second one showing me? It's showing me that this is equal to this. So this diagonal has cut this one in half and this one here is equal to this one here. That's showing me that the diagonals bisect each other. And that tells me that it's a parallelogram. Diagonals bisect each other. Okay, the next one says this side is congruent to this side, and this side is congruent to that side. That's this rule right here that says 2 sets of opposite sides congruent. So this is enough information, opposite sides congruent. Here, let's see what this one says. Well, it says these 2 are congruent, and these 2 are parallel. Is that one of our options here? It's not, and so let's think about what this could be instead of a parallelogram. So this is a no. It's not enough information. And if we think about it, I could have 2 sets of sides that are parallel like this, and I could have 2 sets of sides that are congruent like that, and that would actually make a trapezoid. So this doesn't have to be a parallelogram. This could also make an isosceles trapezoid. So that's a no. Here, we're saying this angle is equal to this angle, and this angle is equal to this angle. So this right here is a no. That's none of our choices up here. And finally, here, I want to add a new little note to you that I think we might have talked about it the other day, but I'll mention it again here. Note the angles in a quadrilateral add up to 360. We talked about how this is really like two triangles and each triangle is 180, so two triangles together would add up to 360. So we can find this missing angle by adding these up and subtracting from 360, and we find that this angle is 120. So this is where consecutive angles are supplementary. These two are supplementary, these two are supplementary, and it has to work going all the way around that all of them, when they're next to each other, they're supplementary. So this is consecutive angles are supplementary. Alright, this one. Now we're going to do the kind of problems where it says, what values prove that this quadrilateral is a parallelogram? So now we're going to use the same kind of rules that we've been seeing to do this. So this first one says RT is 19.8. And it wants to know what the whole thing is. Well, if this is going to be a parallelogram, what do we have to know about the diagonal? The diagonal has to be bisected, and this half has to be equal to this half. Well, if that's 19.8, this is 19.8. So what is the whole length? Well, the whole length would be 19.8 plus 19.8. And that would equal 39.6. Okay, this one, we're missing this angle right here. Well, if you look at our rules, consecutive angles have to be supplementary. So they have to add up to 180. So these together, this one and this one have to equal 180. So this is the one I'm missing here. So I need to add these together. And I get 112, and then I need to take that and subtract from 180. And we get 68. Here, I've got two things I'm looking for. It's looking for this angle. Well, our rule says opposite angles are congruent, so this one has to be 54. And opposite sides are congruent, so if this side is 10, that side has to be 10. Alright, and then our favorite, if we can do it with numbers, we can also do it with algebra. So I really like this first problem, number 10 here, because I've got x's and y's. And you have to decide what you can use to solve. Can I say this is equal to this? Well, I could say that, but I can't solve if I've got an x and a y in one equation. But I can solve with these. I know 3x equals 6, and we can solve that. And I get x equals 2. Now I can plug this in up here and get that this side up here is 4. And now I can say 4 equals y minus 1. So y is 5. Okay, here I see the same thing. I can't just say that these two are equal yet because I'd have an x and a y in my problem. But I can say these are equal, so 2x equals 70, x equals 35. Now I can plug it in on this one, and when I plug it in here, I'm going to get that this is 110, and I'm going to plug this in right here, and I'm going to get 35 equals 3y. Now I can set these two things equal to each other. 110 equals 35 plus 3y. Subtract the 35, and we get 75 equals 3y, divide, and you get y equals 25. And then finally, we know here that the diagonals are bisected. So this is equal to this, and this is equal to this. Which one do I have to start with? Well, this would have an x and a y in it, so I can't start with that. But I can start with this one. 3x equals 12, so that's x equals 4. Now I can plug this in for x right here. And I get that this one is really 4 plus y. Now I can say this is equal to this. So I have 4 plus y equals 5y minus your y. 4 equals 4y, and y equals 1. Okay, watch the second video for part 2.